All right, welcome back, everyone. Ready for another deep dive?
Definitely. Always ready to explore some cutting-edge research.
Well, today we're going to be looking at something that's pushing the boundaries of AI and math, something really cool.
Oh, sounds intriguing. What kind of research are we talking about?
You guys sent in a paper titled BoostStep, Boosting Mathematical Capability of Large Language Models via Improved Single-Step Reasoning.
BoostStep, huh?
Yeah, it's by Baishan Zhang, Yuhong Liu, Shaidong, Yuhong Zhang,
Wow, that's a lot of authors.
Pan Zhang, Hadong Duan, Yuhong Cao, Dahua Lin, and Jiaqi Wang.
Okay, a whole team behind this.
And let me tell you, this paper, it's got some really interesting ideas about how to improve the math skills of large language models. Like,
Okay.
really interesting.
I'm all ears.
Okay, so to kick things off, maybe you can give us a little background. What's the main problem these researchers are trying to solve?
Well, you see, even the most advanced LLMs like GPT-4, those superstars of the AI world,
Yeah, we've talked about them before.
right? They could break down a complex problem into smaller steps, sure, figure out the overall process.
Yeah.
But there's a catch.
Exactly. They often struggle with the accuracy of individual calculations within those steps.
So it's not the big picture they're missing. It's those little details that trip them up.
Exactly. And you know what? The researchers found that a whopping 99.2% of errors in GPT-4's math reasoning came from these little step inaccuracies.
Crazy, right?
No, 99.2%, that's huge. So how does this BoostStep thing, how does that address this issue?
Okay, so picture this. Traditional in-context learning for LLMs is like, you give someone a cookbook, all those recipes at once.
Right, figure it out yourself.
Yeah. But BoostStep is like having a cooking show host, guiding you through each step.
Ooh, I like that analogy.
So BoostStep, instead of just giving the LLM a bunch of solved examples and saying, go learn, it actually provides guidance at every single step. Like, okay, now chop the onions, now add the spices.
So it's more hands-on.
Way more. So imagine, right, the LLM is working through this multi-step problem. It first takes a stab at the current step, just tries it out.
A first draft, kind of?
Exactly. And based on that attempt, the system pulls up a similar, correctly solved step from a database of examples. It's like, hey, remember that time you nailed this? Here's a reminder.
Oh, so it's almost like checking its work with a really, really smart textbook as it goes.
Exactly. And by using that retrieved example as a guide, the LLM can refine its reasoning, make sure it's on the right track.
Okay, that's pretty slick. But what are the real-world advantages? Why should we care about this step-by-step accuracy thing?
Well, first off, the results.
Yeah.
Impressive. Across a range of tests, BoostStep consistently boosts accuracy, sometimes by as much as 4%. And for those really tough problems, like the ones you find in math competitions, the gains are even bigger.
Yeah, 4% might not sound like a lot, but in the world of AI and complex problem solving.
It's a game changer. And it's not just about accuracy. BoostStep also leads to better generalization. It can handle problems that are different from the examples it's seen before.
Ah, so it's more adaptable.
Right. It's like, a student who can grasp the underlying concepts and apply them to new problem-solving scenarios, not just stuck in one way of thinking.
I'm already getting excited about this research. It's not just a small tweak. It's like a whole new way of thinking about how LLMs can learn to reason,
Exactly. And here's the kicker. BoostStep can be seamlessly integrated with something called Monte Carlo tree search, or MCTS.
MCTS. Now, remind me how that works again. It's been a while.
Sure. Imagine the LLM has to make decisions. MCTS is like creating a tree of all the possible paths, those reasoning steps, each branch a different sequence. The LLM explores these paths, sees which one's most likely to lead to the right answer.
So it's like a way for the LLM to systematically try out different options, make sure it doesn't get stuck going down the wrong path.
Exactly. And get this, BoostStep actually makes that exploration process even better. It helps the LLM generate more accurate paths. A and D, pick the best one.
Wow, so it's not just exploring more, it's exploring smarter.
You got it. BoostStep acts as a guide within that whole decision-making process, making sure each step is as accurate and logical as possible.
I'm starting to see why this research is causing such a buzz. It's not just about making LLMs better at math, it's about making them better at the very core of their problem-solving abilities.
Couldn't have put it better myself. And you know what else? The researchers behind BoostStep, they didn't just stop there. They created a special kind of example problem bank to go with it.
Oh yeah, I was just about to ask about that. It seems like the quality of those example problems would be crucial for this whole thing to work.
Absolutely. They didn't just throw any old math problems in there. They went all out to make sure it was tailored to how LLMs learn and reason.
So how did they do that? What's so special about this example bank?
Get this. They used another LLM, GPT-4, to break down existing solutions into steps. But here's the key to Curie. They did it based on the reasoning content, not just the grammatical structure.
So it's not just about parsing sentences, it's about understanding the logic behind each step.
Right, making sure those steps align with how the LLM actually thinks when it's solving problems. It's like giving them a learning resource that speaks their language.
Now that's impressive. It's like they've figured out how to teach LLMs in a way that really clicks with them.
It's a game changer, and it leads to some amazing results. But of course, like any research, there are always areas for improvement.
Okay, so where do we go from here? What are the next steps? What are some of the limitations?
Well, for starters, the example problem bank, as great as it is still kind of limited in size and scope. Expanding it with even more diverse and challenging problems would be key.
So basically more practice for the LM. The more examples it has, the better it gets.
Exactly. And, the retrieval method, how BoostStep finds those relevant examples, there's room for improvement there too. Imagine a retrieval system that truly understands those mathematical concepts, like a personal tutor who knows exactly what you need to see to get it.
That would be incredible.
Right. It's like going from a keyword search to having a super intelligent search engine that actually gets what you're looking for.
This has been an incredible deep dive so far. I feel like I understand this complex topic so much better.
I'm glad to hear that. And believe it or not, this is just the beginning. We've got so much more to explore in this research, like how BoostStep performs on different types of problems, how it interacts with other AI techniques, and the limitations.
Oh, we can't just gloss over the limitations. Gotta keep it real.
Of course, of course. We'll get to all that in the next part of our deep dive.
All right, everyone, stay tuned. We'll be right back after a quick... Wait, no, we're not doing breaks in this episode. We're diving straight back in.
Sounds good to me. More BoostStep, more excitement.
Okay, so I'm ready to get into the nitty-gritty. How did they actually test BoostStep? Did they just throw a bunch of random math problems at it?
Oh, no, they were way more systematic than that. They used the standardized benchmarks, kind of like the SATs for AI, but for math reasoning.
Oh, okay, so real hardcore tests.
Yeah, things like Math 500, Aqua A, Olympiad Bench 2, and Math Bench. They even tested it on problems from the AMC 10 and 12, those crazy hard high school math competitions.
Whoa, so they really put it through its paces.
Yeah.
So how did BoostStep do? Did it pass with flying colors?
It totally aced it. BoostStep consistently outperformed those traditional in-context learning methods across all the benchmarks. And remember how we talked about its improved generalization? That was super evident in the results.
You mean how it can handle problems that are different from the examples it's seen?
Exactly. They even tested it on multimodal math problems, the ones that combine text and images, like from Math Vision and MathVerse.
Oh yeah, those are tough. It's like having to solve a word problem and interpret a diagram at the same time.
Right. And those traditional methods, they really struggled with those. Sometimes they even did worse than if they had no examples at all.
Wow, so those less similar examples were actually throwing them off. But BoostStep, it just kept on trucking.
Exactly. It kept showing those big improvements, proving it can handle all sorts of different problem formats.
So it's like having a solid foundation, right?
Yeah.
Master the fundamentals, and then you can tackle anything.
That's a great way to put it. Yeah. And remember our chat about Monte Carlo tree search? Well, they actually did experiments to see how BoostStep and MCTS work together. And the results, pretty amazing.
Okay, this is where I think things get really interesting. Two powerful techniques combined. Gotta be good, right?
It's like the ultimate AI power couple. They found that BoostStep made both the reasoning and the verification parts of MCTS way better.
Okay, hold on. Break that down for me. What does that mean in, like, normal human language?
Okay, imagine you're in a maze, right? And you have a bunch of explorers trying to find the way out. MCTS is like having them all explore different paths at the same time. In BoostStep, it's like giving each explorer a little helper, a guide that helps them make smarter decisions at every turn.
So it's like a team of super efficient maze runners, all working together.
Right. And at the same time, BoostStep is also helping someone outside the maze figure out which path is the most promising.
So it's improving both the exploration and the decision-making.
Exactly. And the result.
Yeah.
Way better performance than using just MCTS alone.
Okay, so it's not just a small improvement, it's a whole new level of problem solving.
It's like they've figured out a way to make LLMs think more logically, more accurately at every single step.
I'm starting to see why this research is getting everyone so excited. It's not just about math, it's about a whole new way of thinking about AI.
Exactly. It's about making AI more human-like, giving them that ability to learn and reason like we do.
So where do we go from here? What are the next steps, the challenges?
Well, that example problem bank, it's awesome, but it could be even better. A larger, more diverse set of problems would really push BoostStep to its limits.
More practice makes perfect. Even for AI, huh?
You got it. And remember the retrieval system. That's another area ripe for improvement. Imagine if we could make it even smarter, make it understand the math on a deeper level.
So it's like going from a basic Google search to having a personal tutor who knows exactly what you need to learn.
Exactly. That would be a real game changer for BoostStep.
Now that we've talked about the evaluation and the potential for improvement, can we go back to that example problem bank for a minute? You mentioned it was tailor-made. What makes it so special?
Oh yeah. This is where the researchers got really creative. Remember, they used GPT-4 to break down the solutions, but not just based on grammar. They focused on the actual reasoning behind each step.
Right. It's not just about chopping up sentences. It's about understanding the thought process.
Exactly. They wanted to make sure the problem bank reflected how the LLM would actually approach a problem, step by step, and the result. A learning resource that was perfectly aligned with BoostStep's needs.
So it's like they created a custom textbook just for BoostStep.
Right. And they pulled those problems from all sorts of places, like this data set called PRM 800K, which covers a ton of different math topics. And to make things even more challenging, they also included problems from those tough AMC competitions we talked about.
Oh, wow. They really didn't hold back.
No way. They wanted to see what BoostStep could really do.
This whole approach to AI training is just incredible. It's not just about throwing more data at the problem. It's about understanding how these models learn and creating resources that actually work for them.
I totally agree. BoostStep is a perfect example of that. It's about making AI more human-like, more capable of understanding and reasoning.
And this could have applications way beyond math, right? Imagine if we could use this approach for things like writing or coding or even music composition.
The possibilities are endless. We could have AI assistants that can guide us through any complex task, providing feedback and suggestions along the way, helping us learn and create in ways we never thought possible.
This deep dive has been absolutely fascinating. I feel like I've learned so much about the future of AI.
It's an exciting time to be following this field. We're seeing all these incredible advancements, and research like BoostStep is paving the way for a future where AI can truly augment our abilities and help us solve some of the world's most challenging problems.
It's both exciting and a little bit daunting, isn't it?
Yeah, but mostly exciting, I think.
Okay, well, before we get too carried away with all the possibilities, should we get back to the papers or anything else we need to cover?
You know what? There's one more finding I think we should discuss. It really highlights the importance of this research. Remember how we talked about BoostStep's ability to generalize to new problems? Well, they found something really interesting when they compared BoostStep to traditional in-context learning on problems that were quite different from the examples the models had seen.
Okay, I'm all ears. What did they find?
They found that the traditional methods often struggled with these unfamiliar problems, sometimes even doing worse than when they had no examples at all.
Oh no, so it's like those less similar examples were actually hurting their performance.
Exactly. But BoostStep, it was a different story.
I bet. BoostStep probably handled it like a pro.
You know it. Even with those super different problems, BoostStep still showed major improvements. It's like it understood the concepts on a deeper level and could apply that knowledge to any situation.
That's amazing. It really shows that BoostStep isn't just mimicking solutions, it's actually learning how to reason.
Exactly. It's about developing true understanding, not just memorization.
It's like the difference between a student who can regurgitate facts and a student who can actually think critically and apply their knowledge to new situations.
Perfect analogy.
Mm.
And that's what makes this research so groundbreaking. It's showing us that we can create AI that can learn and solve problems in ways we never thought possible.
Welcome back. We've covered a lot of ground, but before we wrap up this deep dive into BoostStep, I want to circle back to that example problem bank. You know, the one that's specifically designed for the way LLMs think.
It's a game changer, honestly. Instead of just using any old math problems, they created a resource that aligns perfectly with how LLMs learn.
Yeah, you mentioned earlier they use GPT-4 to break down solutions based on the reasoning, not just the grammar. Why was that so important?
Well, think about it. If you're teaching someone something new, would you just hand them a textbook full of complicated stuff? Or would you break it down step by step, explaining the logic behind each step?
Oh, definitely the step-by-step approach. It's way easier to understand that way.
Right, and that's exactly what the researchers did here. By using GPT-4 to analyze the reasoning, they created a resource that mirrors the LLM's own thought process.
So it's like they made a personalized textbook tailored just for BoostStep.
Exactly. And they use a variety of sources for the problems. There's this dataset called PRM 800K, covers algebra, calculus, geometry, all sorts of stuff.
So a well-rounded math education for BoostStep.
Exactly. They wanted to make sure it was exposed to all kinds of problems, really challenge its reasoning abilities.
Did they just use like typical textbook exercises?
Nope, they wanted to up the difficulty. They even included problems from those super hard AMC competitions.
Oh, wow. Those are tough. So they were really putting BoostStep through the ringer.
Absolutely. Wanted to see what it could handle, push its limits.
It's amazing how this research is changing the way we think about AI training. It's not just about brute force anymore. It's about understanding how these models learn.
Yeah, BoostStep is a perfect example of that. It's about creating AI that can truly understand and reason, not just mimic solutions.
And this could have implications for so much more than just math, right? What if we could apply this approach to things like writing or coding or even creative stuff like music?
The possibilities are mind-blowing. Imagine AI assistants that can guide us through any complex task, give us feedback, help us learn and create in ways we never thought possible.
This deep dive has been incredible. I feel like I've gotten a glimpse into the future of AI.
It's an exciting time to be involved in this field. We're seeing so many breakthroughs like BoostStep that are pushing the boundaries of what AI can do.
It's inspiring, but also a little bit daunting, right?
Definitely a mix of both.
Yeah.
But mostly I think it's exciting.
Well, thank you so much for taking us on this deep dive. I've learned so much.
It's been my pleasure. Always happy to talk about this stuff.
And to our listeners, thanks for joining us. We'll see you next time for another deep dive into the world of AI.